Okay, sixth grade, our objective today is to solve two-step equations. So I know a lot of you have been waiting for this. I know you're so excited. We're actually going to talk about solving a two-step equation today as opposed to always the one-step. Let me just give you a summary of what this chapter is about. I know a lot of times you guys will ask me questions and I'll say, hold that thought, we'll be getting to it. Well, this is one of those chapters where you guys asked me a couple weeks ago about multi-step equations or x's on both sides. We are getting to all of it in this chapter. We also are going to get to inequalities, which kind of looks like this picture that I have here. So in addition to solving equations, we're going to be solving inequalities in this chapter. I like to mix them up because it's the same process. The only thing difference is one of them has an equal sign, the other one will have some type of inequality sign. This chapter, as well as chapter 2, is extremely important for your building blocks and just your basis for math, because you will always see solving equations no matter what math class you're in. Mary. Probably not like the ones we're going to do, but yeah, I'm sure you're right about that. Doug. Yep. We're going to get to that in a couple days. All right, let's start with going over the warm-up. While you guys are flipping to page 1 in your note package, just remember, no math class this Wednesday. Your test scores are in progress book if you want to check. I'll give them back tomorrow. All right, so the warm-up should have been pretty easy. I didn't want to give you too long of a warm-up since you had to clean out your binder and all that other stuff. So, Justin, what did you get for number 1? Good. Charles, letter B. Nope. Nope. Charles, how do you get the -5 to the other side? Yep. Yep, always do the opposite. Okay. So, Sean, what should we get? Good, -9.5. Briar, letter C. You didn't get that? Okay, Briar, can you tell us letter D? Okay, good. So letter C, because it's going to be a decimal, leave it either as an improper fraction or a mixed number. Adam? Okay, go ahead. Good. Tell me what your decimal is. Okay, negative though, don't forget. Okay, I prefer that you keep it as an improper fraction or a mixed number. Now, I wouldn't mark Adam's wrong. That's right. But to keep it as exact as possible, keep it as an improper fraction or mixed number. Matt? Good. -12/7. What would the mixed number be, just in case someone left it like that? Alyssa? Good. -1 5/7. Any of these is acceptable. I'm going to circle the 2 that I prefer because as we get into longer equations and inequalities, it's good to keep it as accurate as you can. In other words, as exact as you can. But again, I would not mark this wrong. In geometry class in 2 years, that would be wrong. Okay. Any questions on the warm-up? How to do any of them? Okay, so some of you guys were confused on C just because it was not a nice number. Was that the problem? Just give me a head nod so I know what you guys are thinking. Okay. Okay. Yeah, if you ever need them, it's in the not you, Brian, but anyone, in that no slacking anytime cabinet. Feel free to open them and take it out. I just don't take them out every day if we're not using them as part of the lesson. Adam? Yeah, it's irrational. Well, the decimal keeps going and it's not a pattern, but because you can write it as an improper fraction, you categorize it as a rational number. Kind of confusing. So, yes. Annalise. Depending on what the directions say. Okay? Mary? That's fine. That's fine. No, this is the -12/7 is rational, but the way Adam explained the decimal, I would need to look at it. The decimal point seems like it's irrational because it just randomly goes, but something makes it rational. So there must be some kind of pattern, but sometimes you can't see it on the calculator because only so many numbers fit. In other words, if you can write it as an improper fraction or any fraction, it's rational. But sometimes the decimal looks confusing. So that's why, by definition, it says if you can write it as a fraction, it's rational. Okay? Charles? Yeah. Yep. Yeah. You know what? These ones don't. The bar above it means repeating. So these calculators do not show you, like they don't put the bar there. Now the silver edition may. I will have to look into that for you. It doesn't? Okay. So maybe they need to make a more advanced calculator that does that. Okay. Let's go to example 1. Okay, so what we're going to do, I'm going to start off with just some basic examples of solving two-step equations, and then we're going to do some application with word problems. So the important part right now is let me go through a couple examples with you so you understand the process. Remember, too, as we start, you're not going to understand something completely until we do a couple examples. So let's try to hold off on the questions until we try a couple. Sean, go ahead. You were going to say something. That's just wrong because we already wrote these definitions down in chapter 2. It's actually my fault it's a typo because in the book they have them for every section and I should have looked back at everything else before I kept typing. So it's my fault because I made most of these note packets. Jeremy? Yep, exactly. And on the game, the review game. All right, so letter A, two-step equation. Why is it a two-step equation? You're doing 2 steps as opposed to 1. So very first thing you want to do is ask yourself, is there anything that we can add or subtract to the other side? My rule of thumb is keep all the variables on the left, get all the numbers to the right. Just like when we rewrite an equation, rewrite it so the variables on the left, numbers on the right. Okay? Alyssa, what do you think we need to move? Good. Okay, what are we moving? If we want all the numbers to the right, what are we moving to the right? Good. So if we get all the numbers to the right, we want to move that positive 3 to the other side. So add or subtract the numbers first, move them. So when we move that, that's gone on the left side. You want to get all the variables by themselves on the left. So we have negative 14a equals negative 21. The second thing you always do is multiply or divide depending on what the problem looks like. So this is really negative 14 times a. Donatus, how do we get rid of the negative 14? Good. Divide both sides by negative 14, just like we did in chapter 2. We now have a one-step equation. So Alex, what would the answer be? Say that again. Nope, careful. Simplify it. 7 goes into both of them. Good. Positive 3 over 2, which you guys should be able to do mentally. Negative divided by a negative is a positive, and we know 7 goes into each of them. You may also leave this as 1.5 or 1.5. Again, I prefer it to be an improper fraction or a mixed number as opposed to a decimal, but either way. Jeremy? No, improper fraction or mixed number is fine. Annalise? Yep. All right, letter B. Okay, c over negative 4 minus 5 equals 25. Two-step equation. You want all the variables on the left, all the numbers on the right. Briar, what do we need to move on this one? Good. How do we get negative 5 to the other side? Good job. So plus 5, plus 5. Make sure you're with me, guys, and you're showing your work. So add 5 to both sides. We have c over negative 4, just rewrite it, equals 30, because 25 plus 5 is 30. Now we're down to a one-step equation. Thinking back to chapter 2, Doug, how do we get rid of the negative 4? Good. Okay, go ahead. Show your work. Show your work. Until I know that all of you guys know how to solve a two-step equation, show your work. So I need you guys to prove it to me first. Show your work. Show your work, Adam. I know you don't like it at all. Show your work. For now, okay? I promise. It'll make yourself a better math student, especially with solving equations. -4 divided by -4 is 1. They cancel. And the H, what's the answer? Good. C equals -120. All right, so we just did 2 examples of 2-step equations. Not bad, right? Okay, I want you guys and girls to try letters C, D, and E. That's all. Don't go ahead. C, D, and E. When you're done, put your pencil down. Show your work, please. I want to make sure you guys are with me. Okay, you need to finish. Okay. Okay. I don't want you missing. Okay. C, D, E. Show some work. Donatus, put your head up, please. Head up. Okay. Thank you. You gotta follow directions, Doug. Okay. Put your pencil down. C, D, E. Here. Page 1 in the notes. Okay. That's mine. All right, letter C. Matt, what's the first thing we should do on letter C? Good job. So we have H over -5 equals 7. Sean, what did you get for your answer for letter C? Good, because that next step is getting rid of the -5. You need to multiply both sides by it. So very good job. We get -35. Charles, just tell me your answer for letter D. Good. Zach, the new packets are in the back of the room. I'll have you clean out your binder later. Just go ahead and get the new packets. Good job. And then letter E, Annalise, what'd you get? Good job. Any questions on C, D, or E? Emma M. Yes. On a problem like this. Jeremy. Letters. Well, not distributing, subtracting, you mean. Yeah. Yep, they're easy. Those are the easy type of 2-step equations. Okay, let's do letter F together. Zach, what's wrong? Pencil? All right. Okay, so what's different about letter F? What's different, Annalise? Well, I wouldn't call it the answer because remember, they're equivalent. It's not necessarily the answer, but what's on the right-hand side that hasn't been so far? Good, the variable. So I'm going to circle this. We're going to move the variable expression to the left. We're going to move the 2 to the right so that we have D over 5 minus 1 equals 2. Very first thing I want you guys to do is flip them around. So the variable's on the left, the number's on the right. It's minus 1. So once you rewrite it, Justin, now what do we do to solve our 2-step equation? Good. Add 1 to both sides. So we have D over 5 equals 3. Mary, how do we get rid of the 5? Multiply both sides by 5. Adam, what's the answer? Okay, what did you do wrong? That's why I don't want you to go ahead on things like that, okay? So if you need another packet, go ahead and get one. You okay? Okay. Annalise. You're not multiplying 5 times 5. What are you multiplying? Think back to chapter 2. Okay. Yep. So then 5D divided by 5 is 1D. Remember, these always cancel. Okay, think back to chapter 2. All right, let's go to letter G. Okay, letter G. I think this is the last one that I want to do with you guys, and then we'll do some word problems. Okay, 7 minus 4y equals 19. So similar type of setup, but a little different. Emma, how do we get the 7 to the other side? How did you know to subtract it? 7 is really positive. Please don't forget to look in front of the number to see what it is. Since it's positive, you subtract it. So it goes away on both sides. So we're left with negative 4y equals 12. Donata's head up, please. Okay, Emma H., how do we get rid of the negative 4? Good. Divide both sides by negative 4. So your answer is y is equal to negative 3. Don't forget, you can always go back to the original problem, plug negative 3 back in to make sure you're correct. I promise you that's the right answer. Jeremy, question? They do. They do. Okay, I want you to flip over your notes to the next page. I want you to add in, I want to do 2 more harder problems because these are too easy. Okay, I want you to add in letter J. On the next page, halfway down, put letter J. So like right here, put a letter J. Yeah, like halfway down, put a letter J, because we're going to do the word problem in a second, well, a couple minutes. Okay, letter J, I want you to write down negative 2/3 x equals 4. This is a 2-step equation. Negative 2/3 x equals 4. All right, the first thing I want you to do is, if the negative sign is in the middle of the fraction, I want you to cross it off and put it with the numerator. If the negative sign is in the middle of the fraction, cross it off, put it with the numerator. Okay, first step, get rid of the denominator. To get rid of the denominator, we multiply both sides by it. First step, get rid of the denominator. To get rid of it, you multiply it, remember, because these 3's cancel, just like chapter 2. So we are now left with negative 2x equals 12. How do we get rid of the negative 2? Emma H? Good. Divide both sides by negative 2. What do you say? Yeah, I know. So we get x is equal to negative 6. So if you have a fraction that does not have 1 as the numerator, follow the steps of multiply both sides by the denominator to get rid of it, and then divide by the numerator. Does anyone know another way to do this? Adam, did I tell you? Go ahead. Remind me. I didn't know that. Okay, I forgot I told you guys that. Doug, do you have a question? I'm going to do it. Hold on. That's what we just talked. That's what we're talking about. You okay? Okay. So here's the other way. If you put a 1 underneath the 4, instead of doing it in 2 steps, you can do this in 1 step. So what I mean by that, you can take negative 2/3, flip it to get the inverse or reciprocal, which is 3 over negative 2. The 3's cancel and the negative 2's cancel. So you have x is equal to 4 times 3 is 12. You guys all watching? 4 times 3 is 12. 1 times negative 2 is negative 2. 12 over negative 2 is negative, I always do that, is negative 6. I prefer this way, but a lot of times when I teach it, it's easier to do it in 2 steps for a lot of people. That's why I do it this way. Adam? Yes, you could do that. Yep. I just didn't want to go that far today. Go ahead. Yeah, you can call that 4 first. Yeah. Emma M? Yeah. Yep. Yep. Jeremy. This is this lesson's two-step equations. I just showed you how to do it in 2 steps. I also just showed you how to do it in 1 step. No, you get the same answer. Look, we got the same answer. No, you choose whatever method makes more sense to you. I don't believe in, I teach you one thing, you have to do it the way I do it. No. I like to show you guys sometimes a couple methods, and sometimes you might think of something else that someone else showed you. You do the method that you like best and makes most sense to you. Okay? I like this way better. But typically when I teach it, I do it this way. Doug, go ahead real quick. Okay. Okay, cool. All right, one more. Letter K. 4/5 x plus 8 equals 10. Zach, go ahead. What's up? Mm-hmm. Yep. That's like using the cross simplifying. You're just doing it in your head. Yep. Emma M. All right, hold on. Did everyone write down letter K? All right, Emma M, what do you think the first thing is that we need to do? Good. Add or subtract first. So move all the numbers to the right. So -8, -8. We have 4/5 x equals 2. So let's now do this in 2 steps. I think, actually, let me ask you guys. Hold on one second. Looking at this problem again, raise your hand if you like this way better. Oh, raise your hand if you like this way better. Oh, wow. Okay, I'll do it both ways. That's different than last year. Okay, so at this part, someone tell me how to do it in 2 steps. So let's go through both ways. Charles, what's the first thing? Good. So multiply both sides by 5. So to do it in 2 steps, multiply both sides by 5. This cancels. You're left with 4x equals 10. Sean, how do we get rid of the 4? Good. Divide by 4. Good job. So hold on. Shh, I'm going to make sure you raise your hand. So 10/4. I want you guys to simplify. Remember, I don't like decimals as much as I like fractions, improper fractions. 10/4 simplified is what? Simplified. Zach. Good. 5/2, which you can also write as 2.5. Annalise. So did we, right here. You just simplify, okay? 5/2. It's the same thing. You just need to simplify. Okay, so let's do it the other way, and let's make sure that those of you guys, which is most of you, that prefer the other way, that you got the same answer. So the other way, Adam, is what? Good. Multiply both sides by 5/4. So the 5's cancel over here, the 4's cancel over here. We have x is equal to, now you can cross simplify. 2 divided by 2 is 1, 4 divided by 2 is 2. And then multiply across the top, across the bottom, or 2 times 5 is 10, 1 times 4 is 4, 10/4 is 10/4, which reduces to 5/2. So depending on if you like cross simplifying or not, your call how you want to multiply all this mess over here. Briar? Okay, that's fine. That's fine. And it doesn't matter. There's not any right or wrong way of going about this. It's just whatever you think is easier and makes more sense to you. All right. Any questions on this? Doug, question on this? No. We're going to do word problems now. All right. Let's do some word problems. Okay. First one is about Travis and a motorcycle. Okay. So, anyone feel like reading this for us today? Mary, go ahead. Good job. Okay, so the first thing is, what is the variable going to mean in this problem? So when we solve for something, Briar, what is it going to mean? So number of months. Perfect. Okay. Secondly, what is the total in this problem? What's the total? Briar, what's the total? Good job. So first two things I always want you to do in word problems is first, identify what the variable is. You with me? And then also figure out what the total is and put equals whatever the total is. Okay, you'll be less likely to make a mistake. Okay, now let's go back to everything else. We also know the down payment that he made on the motorcycle is $1,100. We also know that he pays monthly payments of $200 so he can pay this thing off. Anyone want to take a guess? How do we write down the down payment on the left-hand side of the equation? How do we show that that was a down payment? Mary, how do we show that? Okay, go ahead. Good job. Okay, so my question was, how do you illustrate that the $1,100 is a down payment? Well, it's positive. Donatus, you with me? It's positive. So plus 1,100 because it's a positive down payment. He made it. He paid it. He gave them that money. Also, the $200 is positive because he promises, or maybe he has to make $200 payments every month. So that's positive. This is one way to write the equation. I prefer that you write it this way because when we get to graphing, this is how we'll set up equations. The 200x plus the down payment he already made equals the total. When we go to solve this, hold on a second, Annalise. How do we get the 1,100 to the other side? So when we go to solve this, Charles, how do we get that to the other side? Good. Subtract it. What would our next step look like? Doug? Say that again. You subtracted wrong. Okay. Okay. All I wanted to know was the next step. So 200x equals 1,200. And then at this point, Charles, how do we get rid of the 200? Good. Divide by 200. So go ahead, Charles. Oh, yeah. You don't need to use long division on this because take the zeros off. 12 divided by 2 is 6. Hand next time, but go ahead. Go ahead. Yeah. Annalise. Yes. Yep. Emma H. Go ahead. Yeah, that's a great way. I like that. Justin? Yep, that's what we did. Oh, yeah. I see what you're saying. Yes, from the beginning. Yeah, you could do that. There are other ways to set this up. Did anyone, if you were a little bit ahead of me, did anyone set it up differently? Mary, what did you do? Okay, yep. Anyone else? Charles, how did you set yours up? Okay, what did you do? Okay, so you basically did these steps, you just did it in your head. Okay. There are some times, though, on a test or a quiz where you will have to write down what the equation is. So make sure that you are comfortable with writing down an equation. There are other ways to write them, so it doesn't have to be exactly what I always do in class because there are equivalent versions of this. Adam, is this a question on this? Okay, go ahead. Oh, yeah, go ahead. Annalise, go ahead. No, you won't get the same answer. You could do 2,300 minus 1,100 equals 200x. If you added these numbers together, you're not going to get the same answer. Plus, it doesn't make sense with what the problem says. Okay? All right, I need you guys to flip to your homework packets, page 44. We're going to do some more word problems together. So flip to your homework packet, page 44, and take a look at number 2. Oh, no. More word problems. What is she doing to us? Number 1 we already did in chapter 2, chapter 2. Page 44 in the homework packet. Take a look at number 2. Okay, number 2 says, we're on page 44, write an equation to find the value of x in the provided triangle. Then solve for x and use the value to find the measure of each angle. Go ahead and write an equation. We've done this before. So number 2, it's a right triangle. Write an equation, please. Do not go any further, just write an equation. Page 44, Sean. Front of page 44. Write an equation. Don't go any further. We're on number 2. 44. Go on. Okay, what equation did you guys use? Annalise, what equation did you use? Good job. 90 plus 3x plus x equals? Good, equals 180. So here's our equation. Yes, you could have these things in a different order. Did anyone have a different equation? Charles? Yep, that works. Emma H? That's perfect. Yep, that's our next step. Annalise? Hold on, I'll show you why. He just zoomed ahead. I'm getting there, hold on. Okay, so next step, combine like terms. So 90 plus 4x equals 180. So let me explain what everyone said. Here's what Emma H said. That works as a acceptable equation. Next step, move 90 to the other side because it's a 2-step equation. We get 4x equals 90. Now here's what Charles said. He said 90 divided by 4. Charles, is that what you said? Yeah. Yep. So Charles said, Annalise, he's way down here. He said 90 divided by 4 equals x. He basically did these steps in his head and wrote this down as his equation. I'm okay with that. You just need to write down some kind of equation. Regardless of those equations you use, because they're all equivalent, what is x? Annalise, what's x? Yep. Nope, you can keep it. You can keep it as 22.5. On this one, I would say because you're finding angles, you're finding degree measurements, so it makes more sense to keep them as decimals, and that's going to happen a lot. So x is 22.5 degrees. I'm going to take this up here. We know that was a right angle. This is 22.5 degrees. So what is this one? What's 3x? What is that angle measurement if now we know what x is? What's this angle measurement, Doug? Okay, which is? I just want the answer. Justin? Good, 67.5 degrees. So we could check our answer. We could add all those up and make sure that they add up to 180, which they do. Questions on a problem like that? Okay, let's do one more together. Okay, I want you to flip over to number 8. We're going to do more of these tomorrow. I just at least wanted to do a couple today. Okay, number 8. Anyone feel like reading this one for us? Emma M, go ahead, nice and loud. Good job. Okay, so first thing, what is x in this problem? What is x, Briar? Good. The number of yoga classes that the person took. Okay. What is the total in this problem? What's the total, Charles? Good. Definitely. A lot of these can be mental math problems because they're only 2-step equations. Yep. So the total is $139.95. All right, can someone tell us something else about the problem that would now go on the left-hand side? So give me one thing. Emma M, give me one thing. Good, 10x. What is the other piece of information that goes on this side, Mary? Good, plus $19.95. Who can tell us why does the X go with the 10 and not the $19.95? So why does the X go here but not here? Annalise? Perfect. This is a one-time deal. You pay for the mat one time, as long as you don't lose it, as long as you don't break it, rip it, whatever. You pay for it once. I have no idea, but it happens. My brother loses things all the time. The X here goes next to the 10 because every time you go to class, you pay $10. Okay, is everyone clear on the setup? Annalise? Well, now we're going to solve. So that's what we're going to do now, is we're going to solve. Briar? Yep, equals 10x. That works. Okay, go ahead and solve. Write down what you get for your answer. Go ahead and solve. If you haven't already, write down what you get for your answer. Man, you guys are speedy today. And you guys are doing a great job. Good. Make sure you write something down for the equation. Okay? Yeah, I know. Did someone just say they like word problems? I'm glad to hear that. Most people tell me that they don't like word problems. Is this your answer? Okay. Shh. Hey. So notice you got to write bigger. Okay. Okay, Jeremy, how many classes? Good job. Awesome. Good job. Any questions on how to solve that? All right. Flip your homework packet to the very first page, practice 3.1. Very good job today with two-step equations. All right, so I want you guys to do 1 to 31. There are word problems on here. They are very similar to the word problems that we did today, so you shouldn't have many problems with it. Tomorrow in class, I think I want to do some more two-step word problems with you and possibly move on depending on how things go with the homework. So 1 to 31, which is all of it. If you need to take your calculator home, that's fine with me. Please make sure you have your number, though, and you don't lose them. They're expensive. Okay? Any questions on what the homework is? So, guys, back and front, for those of you that sometimes don't listen to directions, there's 31 problems. Okay? Check progress book for your tests. They're all on there. The 3 that finished today, they'll be on there today as well. Wednesday, no class unless you really are going to miss me and miss math. You can come hang out, but I don't know how we're going to get you back to school, so don't do that. All right, you guys good? Okay, go ahead and get packed up.